We have been working with quadratic formulas for the last little while, and this is an introductory lesson to Chapter 4, where we are going to explore solving for quadratic formulas further. So if I draw your attention over here, you will see that I have a quadratic formula in vertex form, and I've done a rough sketch of it here. And I've labeled these 2 points here, and these 2 points right here is what we call the x-intercepts, because that is when y equals to 0. So if we were to record the answer on this, we would say x would equal to 2 and 4. But there's also other terms that mean the same things that we will use in this chapter, so you need to be familiar with the vocabulary as well. So 2 other terms that are the same as x-intercepts is called roots and zeros. So if the question was asked you, what are the roots of the function, then you would say x equals to 2 and 4. Same thing with zeros. X is equal to 2 and 4. The zeros is called that way because if you look at the function back over here, that when x is equal to 2 and when x is equal to 4, the y value is equal to 0. So that's why we call that the zeros. For this section of the chapter, all we will do is analyze these graphs visually by graphing the functions and looking at the x-intercepts, or what we call the roots, and the zeros. So let's look at 3 possible scenarios that can happen. So if we look at the first graph over here, you will notice that this parabola crosses the x-axis at 2 separate points here and here. So if we were to do a general analysis to describe the situation, we would describe this as having 2 different real roots, because this parabola crosses the x-axis at 2 different points. But if we had another scenario, we can have a parabola that just touches the x-axis at just 1 point over here, and we would describe that as one of 2 ways. One way is 1 distinct root, or the other way, if we call that 2 equal real roots, because we have this arm of the parabola coming in, and then it goes in and out at the same point. So therefore, we call that 2 equal real roots, and we'll explain further why that is in the next chapter in 4.2. The last possible scenario is if we have a parabola that was like this. Okay? So you see this parabola here, it will never cross the x-axis at all, right? Because of where it's situated. Now this same scenario would happen if the parabola was opening down somewhere here. That will never touch the x-axis as well. In those cases, if there is no way that the quadratic function will cross the x-axis, we would describe this as no real roots. So those are the 3 scenarios that we're looking at. So remember that when we're looking at x-intercepts, we are asking the same thing, looking for roots and zeros, and these are the 3 scenarios again.